myself Aastha Sharma. I am BTech first year student in the Department of Data Science and Artificial Intelligence here in IIT Roorkee. So today I am going to give a presentation on the topic printing prime numbers between any two given numbers. So let's get started. So for today, our problem statement is print prime numbers between any two given numbers. These numbers would be given to us by the users. So the program need to prompt the user to enter two integers, lower and upper bound, and then print all the prime numbers between those integers. So here basically these two integers will act as a range, and we need to print the prime numbers that come inside that range. For example, input is enter lower bound, let's say 10, enter upper bound, let's say 35. So output would look like this. Prime numbers between 10 and 35 are 11, 13, 17, 19, 23, 29 and 31. So before getting into our algorithm and code, let's have a basic idea of what is a prime number. So basically, prime number is a number that has no divisors other than 1 in itself, whereas the numbers which has more than two factors are called as composite numbers. So as here you can see, 2, 3, 5, 11, 17, 13, etc. are some of the prime numbers. And the point to note here is that one is neither a prime number nor a composite number. Here, as you can see, 14 can be written as a product of three factors, 1 cross 2 cross 7. Since it has more than two factors, it won't be considered as a prime number and it would fall under the category of composite number. On the other hand, 13 can be broken into the product of only two factors, that is 1 cross 13, so it will be considered as a prime number. Now, let's get to our algorithm for this problem. So step 1 is input the two integers, that is lower and upper bound, from the user. Step 2 is initializing a loop to iterate through each number from low to high. We will look into the loop in just few moments in our code. And the step 3 is for each number in the range, check if it is a prime number or not. And for this particular step, we will see the use of function, how we will use here. And for this particular code, I have used a function named isPrime, which I will show you in next 2 to 3 slides. And the step 4 is print the number if it is prime, and we have to repeat the process until all the numbers in the range are 3. Here I used a word function. So what is function? A function is basically a block of code that performs specific tasks and can be called from various points in a program to execute that particular task whenever required. So function just helps us to reduce the code duplication, as we need not to copy paste the same thing again and again to perform the same thing. We just need to define a function and we can call it anywhere whenever required in our code. So this is how our code for this particular statement would look like. So let's understand the code in IDE. Here firstly you would see some green lines. So basically these green lines are the comments. These comments are not the actual part of the code. These are just added to enhance the readability and documentation of our code. So whenever someone else reads our code, he would get to know that what anything stands for and what we are going to do in particular step. So this is just to enhance the readability. Now let's get to our basic outline of our code. Hashtag include IOString. This is the standard library which allows us to do basic output and input operations. Using namespace std, this particular things enables us to use the words like cout and cin. So cout is used to print something and cin is used to take the input from the user. Now again, this is the comment, that is function for checking the prime. This means that we are defining here our function. IsPrime is the name of function, as I have told you earlier. This bool thing is the data type. Since my function is returning true or false, and these true or false come under the category of bool, so data type here is bool. Now here is the loop inside my function. For int I is equal to 2, int I is equal to 2. This thing is the initialization. I less than equal to num by 2. This thing is the condition up to which loop will continue, and I plus plus is the increment. Here instead of using I less than equal to num, I use I less than equal to num by 2, because if a number is non-prime, then it would have the divisors which are less than or equal to half of itself. So I can also use I less than equal to num, but I use I less than equal to num by 2 to enhance the efficiency and to reduce the time taken to perform this code. Now, if num modulo I equal 0, this particular thing means that if my number, if the remainder when my number is divided by I equal to 0, this means that the number is not prime. So it will return false, that is number is not prime. Otherwise, it will return true. Now entering into our main function, similarly int is the data type here. Firstly, I choose two variables num1 and num2 and their data type is integer. Num1 basically represent the lower bound and num2 basically represent the upper bound between which our prime numbers would be printed. Cout, enter lower bound, this thing will be printed on our output screen, and cin means we are taking the input of num1 from the user, and same thing is done for the upper bound. Now here I have defined two conditions here. So the first condition is if num1 less than 1 and num2 greater than 1. Here and is the AND operator. So the condition under, so the code under the AND operator would be executed only if both the conditions are true. This means that this particular line would be printed only if num1 is less than 1 and num2 is greater than 1. So now I will explain this condition. So let's say my num1 is -5 and my num2 is 16. So there are many prime numbers between -5 and 16, but since the prime numbers are positive integers, so I need to shift my lower bound from num1, that is -5, to 2, because 2 is the smallest prime number possible. So I have done the same thing, that if num1 is less than 1 and num2 is greater than 1, this means these both two conditions need to be satisfied. In that case, I will shift my lower bound from num1 to 2 and will print this thing. And if num2 is less than 2, means if num1 is less than 1 and num2 is also less than 2, this means that there is no prime numbers in the range, because num1 is negative and num2 is also less than 2 and 2 is the smallest prime number, so we don't have any prime numbers in the range defined by the user. So here I will simply print invalid input. Please ensure one number is positive and greater than 1. Now again I have defined one loop here for int I is equal to num1. This is again the initialization of my loop here. I less than equal to num2, this is the condition, and I plus plus. This means that my loop will start from num1, will continue up to num2, and there will be the increment of +1 in the I. Means if let's say my num1 is 3 and my num2 is 7, so my loop will be checking for 3. So my loop will continue from 3, 4, 5, 6 and 7, and after 7 my loop will stop and the code is completed. Now again, if is prime, here I am calling my function that I have defined earlier. Let's is prime I. Let me take an example to explain this entire code. Let num1 is 5 and num2 is 15. So here I will start from 5 and will go up to 16. So firstly is prime 5. This will go here. So here is prime, num will be counted as 5. So num is 5. So num by 2 will be 2.5, but we will consider it as a 2. So int I is equal to 2, I less than equal to 2.5 and I plus plus. So if num modulo I, here num is 5 and modulo I, and I firstly is 2. So remainder of 5 when divided by 2, it is not equal to 0. This means next condition will be next condition will be checked, that is when I is equal to 3. 5 divided by 3, here again integer remainder is not equal to 0. This means this condition is false. That means our integer 5 is a prime number. So this particular thing will return true. This means is prime 5 is true. Hence cout I. So 5 will get printed. In the similar way, next is increment is I plus plus. So now we will check for 6. This 6 will again go here and we will check the condition from I is equal to 2 to I less than equal to 3. Since remainder of 6 when divided by 2 is equal to 0, so it will return false. This means that 6 is not a prime number. So here 6 will not be printed. So this loop will be continued from 5 to 15 until all the numbers inside this range are checked whether they are prime or not, and then our code is finished. Let's have an example by running this code here. Let me enter the lower bound be 15 here and upper bound be 50. So you can see prime numbers between 5 and 15 are 5, 7, 11, 13. Let me show some examples. Let me again show some examples by taking negative integers here. Let's say lower bound be let's say lower bound be minus 5 and upper bound be 16. So here, since prime numbers are positive, we will consider lower bound to be 2. So lower bound is shifted from minus 5 to 2, and the prime numbers between 2 and 16 are 2, 3, 5, 7, 11 and 13. Let me again show you one example when both the lower and upper bound integers are negative. Let's say our lower bound is minus 10 and our upper bound is minus 2. So you can see here it will show invalid input. Please ensure one number is positive and greater than 1. Now again, getting back into our code, here is the basic explanation which I have already explained to you. So here we can also face some special cases that if both upper and lower bound integers are equal. In this particular case, our code will check if the single number is prime or not and will print accordingly. And if no prime numbers are found, the program will simply not print anything after the message. Let me show you the example by running the code for these two special cases also. Let's say lower bound be 24 and upper bound be 26. Since there is no prime numbers between this range, so it won't print anything after the message. And if both the upper bound and lower bound integers are equal, what would happen in that case? Let's say lower bound be 3 and upper bound be also 3. So it will print prime numbers between 3 and 3 are 3 because 3 is a prime number. So here we have completed our special cases also. So here we have successfully created a program that finds and print the prime number between any two given numbers. And here we also saw the use of function, and our function name here was isPrime. This helps us to make the code easier to read and debug. So thank you very much.